All right. So before the break, before lunch, we had just been looking at this awesome zip function, and someone had pointed out, and actually I learned that we can indeed use it with dictionaries. However, it's really, I think, most useful with lists. And we saw a couple really interesting things. One is that what zip does, and I think I'll show the list example first, is it's going to take each item in each of these two lists and combine them together into a set of tuples, right? And we see here the first element from each list has been combined into a pair of tuples. The second has, and the third has, and so on. Um, we also saw that zip can spit out, instead of mashing lists into another list, it can mash lists into a dictionary, which can also be really useful. Because again, programming is all about data. It's going to and it's all about data coming from the real world or other programs. And then we have to format and organize it in the way that we need to do what we want our code to do. And we also saw that, zip returns this special object of type zip, basically. Um, and in fact, when we do this list, when we convert a zip to a list or a dict, it empties out whatever was here in the zip. And if I do this twice, I don't get two different things. I just get one. And I think the way to think about this is that this is an in place modification of nums and letters. Like I can only convert, once I've converted from like a zip to a list, there's nothing left in there. So you would do one or the other. And then the last thing that we saw is that if I want to combine lists, I can use zip to combine three lists into tuples. I think also a good warm up activity could be very briefly talking about the set data structure because we didn't touch on that one. We will not see it a ton, but it is good to know it exists. And anyone want to give me like a 5 second overview of what a set is?
Sure. A set is very much like a list, except they have to be unique values. So it's very
Yeah.
close to a dictionary in that way with the keys.
Um, yes, though, yeah, dictionary keys need to be unique. That is true. The values can be whatever. Each item in the set needs to be unique. A set is explicitly unordered. So if we need stuff in an order, the set is the wrong tool to use. And this comes from the set in mathematics, which is where each thing in the set is unique. And I can create a set with curly braces like this. Um, and now if I say, and I can put whatever I want in here. I can say hello. I'm not sure if it likes lists. I'm not sure if a set will allow a list or not. Yeah. Um, I'm pretty darn sure dictionaries, lists, sets, the more complex data types cannot be put into sets because part of how Python makes sure that everything in the set is unique is with something called hashing.
So lists can easily, you can cast a list into a set and it'll just remove the duplicate values. But right now you're using an
Oh, that is
object.
cool. Yeah, let's take a look at that in a second. So here, in fact, we see when I'm creating this set, and actually this is exactly like you were saying. Like I have a duplicate value, but when I create the set, it just ignores it. Um, in terms of putting things into a set, I'm actually not sure if set has an append method. It does have an add method. And I'm pretty sure if we add the same thing over and over to the set, it will again just get ignored. So we don't get errors, but this will just get ignored, I think. And indeed, we see that I can add the same thing to a set over and over and it'll get ignored. So, this could be a potential gotcha with the set, but it does make it very useful for certain things. You can also make a set like this. You can use the set keyword, and you can just, and exactly like you were saying, actually, this is where we need to put in the list. Um, and cast a list into a set, and then it will get rid of duplicate values. And this is a nice way, maybe, to find all the unique values in a list. Um, and and to do other things. Do folks have any questions about sets before we move on?
I mean, it looks like even though you said it's unordered, it's sorting data types too. So all the integers, are all together and then a string.
Um, is it ordered? Good question. Oh, first off, I'm a little surprised I didn't see my another set. I'm a little surprised I'm not seeing this printed out. Here we go. I must have just forgotten to save the file. So, I, order. I, I would have to look it up, but I think it's more about like what guarantees is the Python language giving us. And I'm not necessarily sure that Python is going to guarantee that, like, if I want to iterate through a set, that it preserves this order of things.
Yeah,
I'm not even sure if we can iterate through a set.
I was saying it looks like maybe on the initial creation, it'll sort of sort by type, but then if you add something, then it won't, it won't,
Oh,
it'll just add that item to the end.
oh yeah, yeah. No, it's definitely not sorting. This is just because of the order that I put stuff in. Like if we print this out, now we'll see 5,000 here. I think. No, I was totally wrong. You know what? I apologize. I think you were right. I wonder if that's a function of how sort of the set hashes stuff. That would be something interesting to dig into more. I'm actually not sure about sets and sorting. Um, we can take a quick look, but I don't want to get too lost in it. Yeah, if someone wants to dig into it, I'd be curious to learn. But again, like you can always use a tool for all sorts of things. Like I could hammer in a screw to the wall, but the tools are designed for certain things, and lists are really designed for keeping things in a certain order. Um, Sets, I'm not sure how strong the guarantees of ordering and sorting are, but that would be interesting to dig into and would take us into the guts of Python a bit more. And you were totally right. It does indeed do some sort of sorting when we put these things in, which is interesting to see, and really cool. Any other thoughts or questions about sets before we move on? Okay. And that is a really interesting question, actually. I do want to look into that a bit because that's cool that it's doing that. And I actually don't know a ton about Python sets and don't use them a ton. Um, so I think they're very useful for what they do. Let's talk about air handling with what's called try and accept.
It's with an E.
What was that?
It's except with an E, like
Oh
exception.
my God. Yeah, definitely after lunch. Thank you. So here's the deal with errors and air handling. Where where do errors come from? They come from user input. They come from external data, right? They come when data is invalid, um, corrupted, or unexpected. If our program talks to other programs over the internet, like if my Python code is making an HTTP request to some REST API to get a bunch of data and the server is down, my Python program might wait forever for a response that never comes, right? So again, it usually comes from interactions with other programs and systems outside our program. It could also come from other things interfering with our program. Though the biggest source of errors is really programmer error and the code fighting itself, for lack of a better term. Um, because software is so complicated that even if I'm writing my own program, eventually I'll make a mistake. And so there's this concept called defensive programming where you try to write code that can handle errors well. Because the reality is, we are going to produce tons of errors. And if I kind of code in a fashion that surfaces that, I make my life easier. Um, what to do with errors? This is actually counterintuitive. Let me say that again. What to do with errors is counterintuitive. Usually, you want your program to break if something is not right. You want the error. Now, there's a huge asterisk that goes along with this. Because if we're building a web app for Nordstrom's and it's live and we have customers, I don't want the website to break for customers, for users, right? But if I'm developing software and a new feature's under production or being worked on by me and it's not launched yet, I actually want to see the error message and to see my program break right when it happens so I can fix it and so I can debugging it. So when you are developing, you want to fail fast. You want your program to break early and often and to see all those error messages. Once your code works, or when you are getting code ready to be live for users, then graceful error handling. So the website doesn't break if the user enters a bad value into a form is important, right? Graceful error handling so that errors don't break the whole program is important when things are live and deployed into production. When we're developing, we actually want to see the errors and we want stuff to break early and often. There are sometimes errors you actually, even in production, like you want it to cause trouble. because it means something is wrong and it needs to be fixed, but that's a little more complex. What really matters for us is we're going to learn how to do air handling, get the code working first, then add air handling. Otherwise, debugging is really hard because you never see the errors. So let's talk about how to do this. If I have code that I think might go wrong, I put it in a try block. This is going to throw an error, line 39, because I can't add a string and a number together. Note the red squiggly here. That's because a try block has to have an except or a finally. So if an error happens, it will be handled in the except block. So let me run this and let's watch what happens. So if I walk through the flow of execution, we create the variable A, we create the variable B, we create the variable C, we add A and B together, we add 1 and 2 to get 3, and I know that that succeeded because I see this print statement printing out on line 37. We get to line 39. I don't see the print statement on line 40. I do see the print statement for my error, for my except block. So I know that the error must have been here on line 39. Now, that said, if I'm like developing a feature, this is actually what I like to do. And let me unindent this stuff so Python will be happy. I like this way better because the error message gives me the information I need to debug my program, right? Now I can debug my program. I can say, oh, you know what? This actually, I'm going to have to do this. And also, I have to make some decisions about what I want my code to do.
I was kind of thinking this yesterday. I'm kind of having the same thought now, so I'm not really
Mhm.
sure how to ask you, but
Mhm.
like, what is the purpose of this? If we're going to be writing the code and trying to run the code to make sure that the code works, it's going to give us errors anyway. So, like, what is the benefit of, actually going
Right.
through the extra?
The try except block. Right. Exactly.
Yeah.
So when you mean like, what's the benefit of the try except block?
Yeah, I guess just testing in general, with actual code instead of just, I feel like you'd be manually testing the whole time you're writing code anyways.
Right. Um, so let's say like I'm done writing my code and I figured out this does what I want to do, and I don't realize there's an error here. I've missed it. Um, or often the error isn't from my code, it's maybe like this is user input. Maybe like the user fills out a form on a website and I forgot to handle what if they put in donuts instead of a number. And so when most of the users fill out the form, everything works fine. But then, for 1 in 100 users, someone writes donuts. And then the web server breaks and the website breaks for the user. And even worse, maybe this crashes the whole web server for all the users. Does that help sort of illustrate the importance of air handling for the real world scenario?
Yeah.
Yeah. And that was a great question. Because you touched on a really important point. Um, most errors come from like data or something coming outside of our program that we don't have control of, right? I don't control what forms the user puts in on that form. Also, you got to remember, like, not every error is going to be easy to catch or easy to find or easy to see, because like people will spend days sometimes just trying to reproduce a bug that a user's reported as these things get more complicated. So this is a good practice, right? The same way, say, we have like fire extinguishers in every house. But again, when I'm writing the code for the first time, I would not put this in there because I want to see the error messages. But then when it's done, to sort of make it fail gracefully for a real world situation with users, we would do the error handling. So, if one user puts in donuts when they should have put their age, it doesn't crash the web server for everyone. Yeah, great question. Great question. Let me show and actually any other questions around try accept before I'm going to add more to this, but I just want to see if there's other stuff on people's minds. Okay, cool. We can do more with try accept. We can handle success with an else block. With like if else. And there's an error right here, so we're not getting into the else block. But now we are, right? So this is a lot like, if statements, but for sort of handling more general things, and anything that produces an error in here will be handled. And there's also something called a finally block. And this runs for success or for error. Right, so we see this there. And then if I throw the error, we won't see everything worked, the message in our else, in our success block, but we do see the message in our error block and the finally block. So this lets us do a lot of control flow because, if there's an error, maybe I need to, I don't know, reconnect to the database or something. If it succeeds, maybe I want to, I don't know, save something to the database. And, maybe I always want to do something no matter what. We can also capture error messages. And let me make sure I get this format right, actually, because I feel like I'm about to get this wrong. So give me 1 second. Yeah. So when an error happens, it's referred to as an exception. And we can use this statement E, and then we can print out the error itself. Now, there's not going to be a lot of information in this one. Actually, that one was pretty good. Unsupported operand types for plus, int and string. So we actually saw a good error message here. So there's a lot we can do with this. You can even get like pretty fancy, and you can have different accept blocks for like different kinds of errors. Like let's print Q. Let's print something that doesn't exist. Let's see if I got this right. Yeah, it didn't go into the reference error block the way I hoped. it must not be that kind of air. Um, maybe there's an undefined air. There's definitely a type air.
Is it a value error?
It could be a value air. I don't know the air types all that well. Incorrect argument value. There's a lot of different kinds of airs. And to be honest, it's more situation specific. Like I'll look it up when I need it. It looks like it's not throwing in there. To figure it out, what we could do is uncomment this and run it. And let's see what kind of error this throws when it's just E. It's a name error. And let me uncomment this or we'll get the same error. There we go. So I could get fancy and write different accept blocks for different kinds of errors. This is not a name error, so it should go in the other accept block. And we see that this error gets handled here. Right? So as our programs get bigger, this starts to become more useful. To start out with, don't worry about this because as you can see, it gets pretty specific. Any questions about try except blocks or things that people are curious about?
So when you say the word exception, that's literally like anything under the sun that's an error versus you specify name errors, specifically that type of error.
Yeah,
Do you, okay.
yeah, exactly. I actually had to look at the VS Code hint, but pretty much what it says, it's the common base class for all non-exit exceptions. Like this is a special kind of exception. Yeah, great question. What else is on people's minds? Okay, let's talk about file paths, modules, importing, stuff like that. Let me go ahead and close this one out. Let me make a directory. We'll call it just my project, and we'll go inside there. Let me open up VS Code here so we can have this as a common frame of reference. And so we're going to talk about file paths. We're going to talk about opening files, and we'll see try except actually matter here because this is a great example of if I screw up a file path, it throws a certain kind of error. And then we'll see testing with Python. And I'm going to put a README file here just for reference to help everyone see where the project root directory is, since that's what all the assignment repos are like, and for orientation. And let me bump up the font size a bit. Well, how's that? Can everyone read that okay? Okay, awesome. And just one moment.
You're muted.
Man, sorry. And Chase, thank you so much. Now I understand what you were saying to me. Sorry, guys. Thank you. Well, I'll re-repeat myself. In Python, every file is a module. That's all I was saying. I was just saying it 2 or 3 times to try and drive the point home. We talked a little bit about namespacing yesterday and scope, right? Let's see this in action. Let me just make a split. Python modules have a scope and namespacing. So stuff I create inside a module, inside a file, is scoped to that module. You'll also hear the word module used to talk about when we import libraries and stuff like that, because it can be used for that as well. So just like if I'm talking about, a container, it could be a cardboard box or a shipping container. It could be small or massive. A module can be tiny or big. It's a container. I'm importing the file to Python module. And the module has the same name as the file, but without the the file extension at the end of it, the .py. And I'm going to run this code just as a sanity check to make sure I didn't break anything and that I imported correctly. A couple interesting things happened. Look at these 3 print statements here. The first print here is over here from file 2. Because if we look at the flow of execution, Python imported this module, and as part of importing it, it ran it. Now, if I comment this out and we don't import the module, we see what we would more normally expect. So importing a module executes it. And over here, if I comment this out, well, we execute file 2. Did I save? I did not save. Let's try that one more time. I run file 1. We're still importing file 2, but the print statement is commented out. And I have the same variable in both of these Python modules, and the variable has the same name, but I don't get an error. Because when the Python runtime is executing our code, once we start having modules, we get namespacing. The same way that, if I had over here, the variable with the same name inside a function, like we were talking about scope. And when I say namespacing and scope, they're very similar, if not sometimes the same concepts. Functions create scope in Python. I don't think if blocks create scope. I'd have to check, to be totally honest. And modules creates scope. And since every file is a module, files create scope. Right? And so if I comment this out, it looks a level up in the scope. It looks at the scope, a level up, and it uses that variable. And if this was commented out, we would get an error. So where this comes into play with modules is that when I've imported this module, I've also got access to all of the top level objects, everything in it. Right? So this print statement right here on line 6, I can access anything I create here in the top level scope of this other module. Like, say, a function. Right? That's a little macabre. But we've just seen how we can better organize our code with Python modules that give us namespacing. It is important that these two files are in the same level in the project. I think if I add a dot, that will work fine. I'm not going to lie. The relative import paths in Python always confuse the heck out of me. Yeah,
I believe you need a forward slash after the period.
maybe. I'm not sure. Yeah, that's with JavaScript, you'd be correct. With Python, it's like so let's import say by so I don't cause a name conflict. And let's see if this works. Attempted relative import with no known parent package.
You don't need do you need the dot before file 2?
I don't. I wanted to show that I wanted to show how to use it because it will come up later, but we can see it. We can see it later. This will work just fine. I can add more things here. Now, if I import this foo as well, I kind of run into an interesting issue. If I print foo right here, we'll see the file 2 value of foo, but then when I redefine it and print it again, we'll see the file 1 value of foo. Right? We see file 1 foo is, let's see here. Gonna name it so I can more easily tell what is what. So right here, this third print statement is here because Python executes from top to bottom, right? Our flow of execution. So on line 3, the only foo that exists here is this file. And it goes to line, is imported from this module. Goes to line 4, line 5, line 6, line 7, line 8, we print foo, blah, 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 blah. Line 15, we redefine foo, we print out the new one. Now, if I don't want this to happen, I can use as to give this a sort of variable name or alias. And now I get a red squiggly here because foo doesn't exist yet, but foo2 does. And now I can have all the foos I want with whatever names I want. Python relative paths is a thing. It can also depend a bit on like the virtual environment. And I always kind of confuse myself with it. So I'm not sure I want to get into it right now. Though, James, if there's anything key that I'm missing that comes to mind, let me know. Because I do remember, I think relative import is always a bit tricky. And I'm doing a quick Google search to refresh myself on this. And let's see if I can get this right. Let's make file3.py and let's open it up here. I'll just put file3. And let's just say bar equals bar from file3. And I think the way to do a relative import. So this is import a whole module. This is import specific things from a module and alias them. I'm not sure I can do both of these together since this imports everything and then this is the same thing. So let's make this file3, just so we don't have that issue. And let me make another file. And let's make this foo, and we'll call that foo from file3. Now let's open up file4. Let's see if I can get our relative import correct here. I think it's like this, from dot import file4. Yeah, I apologize. I will come back to this one because I'm kind of circling right now and not getting it to work. So I will share a good example of this later in Slack, I think. I realize I had a couple twists and turns there, but I do want to see if folks have any questions or things you're curious about with imports from the stuff we did cover and get working. Let me rename this to runner so it's easier for people to see later. Okay. Let's talk about files that are not Python files. And then after that, I think we'll take a break. How are we doing in terms of energy? Do you guys want to break now or keep rolling?
I think we
Okay,
could finish
let's
this
do it.
topic
I'm
and then
fine with
break.
finishing out files.
Yeah. Working with files. The Python standard library has a library called OS. It stands for operating system. As you can see from this VS Code autocomplete that popped up, we can use it to get file paths, directory paths, all sorts of useful things. to get the absolute path of where this is, of the current directory, I can use this command os.path, absolute path, and dot for the current working directory. Now, if I navigate up a directory, so that to run this program, I have to do Python my project, working with files. Let me show both. Let's look at these two different paths. This one here, right, went to 04, Pytest, Python. This one here was in the my project directory. So this is absolute path to where the Python program was executed from, not where the file lives. Not where the file lives. We can do a bunch of other stuff with os.path. I think if we just do absolute path, it will give us maybe the current working path. I honestly, whenever I have to use this, I have to look up the docs a bit, so I don't want to try and fiddle around with it too much. But there's stuff with base names, there's a common path, a current directory, a directory name. Absolute path is usually the one we're going to use the most. Let's see this, though, with working with files. But this is the main thing to remember, that you have to think about where am I executing my program from? And usually that's more important than where the file lives, right? And does that make sense to everyone from that example here? Because that's a key point. Cool, awesome. And I appreciate the thumbs up. So I have the Zoom grid open and I'm hopping back and forth, so that kind of helps me see what's going on. Let me just make a text file real quick. I'll just say, we'll maybe deal with CSV data, but for now, I'll just put like hello world into it. We're going to use this Python command called with that does a lot of error handling for us. And we're going to use this command open. And as you can kind of see from this, there's a lot of options we can give it. We're going to give it a file path. We can tell it if we want to open the file for read-only mode for safety, if it's something that I don't want my program to accidentally mess with, or if we're going to write to it, and a bunch of other things. And I'm going to give it the relative path to where my file is. And we're going to open it up in read-only mode. And I'm going to say as and give this a name for us to work with. And what with and open do for us is they will break the file up into separate lines based on hitting enter. And there's not a lot in there right now, right? If I open up the example file, there's really not a lot in there. But let's run this and just make sure it works, and then we can play around. And indeed, I have a typo. I love running my code and finding simple errors to fix. And this is why it's great to run code every 5 seconds. Let me comment out that print statement. Let's add a couple more lines here. I'm not quite sure what is sneaking in the extra empty line, but you can see here that what Python is doing for me is it's breaking up the file by the new line character. there's an invisible, whenever you hit enter, it actually adds a character, and that probably has an ASCII code as well, /n, that's a new line or a carriage return, and editors just don't show it. But that's how Python knows when it looks at the file itself to break it up, because this is actually at the end of every line.
I think one thing we learned in Foundations is if you use the strip method, that'll make it so the lines are single spaced, because I think it's trying
Which
to take
method?
so if you go line.strip, so line 15 working with files.py,
Oh,
line.strip, that takes away all the white space. Oh no, in line
oh,
15.
I see.
Yeah.
Got it. Yeah, that's a great call. Yeah, I'm not sure where the white space came in. Let's see if that takes care of it. Nice. Thank you. That's
It's because
awesome.
you're in your text file, you've got an invisible carriage return, like you said, but every time you invoke the print method automatically creates a new line.
Adds
So you're getting
another.
so you're getting two.
Yeah, that totally makes sense. That makes perfect sense. And in fact, I'm sure we can add to print a special argument so it adds no new line character at the end. So if we did print line end equals empty string, we get the same thing. Yeah. Thank you so much for mentioning strip. That is cool. And this is cool to see as well. So we've got our file open. I like this way. This way simple. Let's play around a bit with this. Right now, I'm in the same directory that the text file is. Let me move a level up, right? So now the text file is inside the My Project directory. So let me run My Project working with files, and let's see what happens. And unfortunately, I didn't seem to be able to open my text file, and I got an error. And can someone maybe break down for me, why did I get this error here? Why does it say no such file or directory /example.txt? Like, it's right there. It worked a moment ago. These two files are right next to each other. What's going wrong?
You gotta import it.
It's not an issue of importing, but it does have to do with files and paths.
It's because you're not in the file that example txt is in, right?
Yeah. So this relative path means that when this code is executed, it's looking in the same directory for this file. Because I moved a directory up, even though the Python file is in this My Project directory, right? The file is over in here, and I apologize because I should have, let's actually do it this way. Make dir other project. And let's move example. Oh, 1 second. Let's make a directory and let's call it your project. Let's move example.txt into your project. Let's move working with files into your project. There we go. And now over here, everyone on the left side of the screen, we can use this to see what's going on. And let's go into your project. So I'm in the your project directory. I run this. This works great. And I think it's intuitive that the relative path, right, means that this is looking here for this. I navigate a level up. And so I'm now I'm a level up outside your project. I run my program, but even though the Python program lives inside here, it's being executed a level up, right? And so this relative path is not about where this file lives. It's where I run the Python program from. And so now, it's trying to find example.txt in this my project directory, and it's not there. Does that make sense? And do folks have any questions around this? Because this is a key point. This is one of the biggest gotchas, I think. Awesome.
Kind of goes back to the point. If you took the intro to programming or the foundations, like the first thing they said was when you're using Linux, know who you are, know where you are.
Yeah, it's great advice. Know where you are. And to add to that, when we run a Python program, our code is being executed from the directory we execute it in, not where the file lives. Right? When I run a program, it's getting executed from the directory, from the location I'm running it in, not where the file lives. I could do Python home directory code. Oh, I don't know. There's got to be a million Python files in here. Or like Python code, platoon, assignments, algo, 99 bottles py, right? So this is way somewhere else in the file system, but this Python program is getting executed from this directory. And it's the same thing here. And this is why like project organization and knowing the project root directory is important, because you need to work with relative paths. Because what's the problem with if I have like users / Adam C / it's like Zulu demos? What's the problem with an absolute path?
Your user's not going to have that path available to them.
Exactly. When I share this code with all of you to collaborate on, that's not your path. Or when we run this code on a server in the cloud, that's not the path because it's a different computer, it's a different file system. I've got a Mac with Linux, it might be different. It might be from a different location. So we need relative paths, but we need a frame of reference. And that project root directory, where we put the README, that's the frame of reference. And so everything is sort of relative from the project root directory when we're working with paths and imports and stuff like that. You can get an absolute path. I could do if I import, I already imported OS. If I do, sometimes you might need to grab an existing absolute path to work with it. And let me navigate into the your project directory. And I just need to uncomment all of this stuff. So I can grab this absolute path. Let me close the old one out. Sorry about that. And I have to rewrite the absolute path stuff, but that's fine. I forgot to save. So this is kind of useful because, I can, as long as I have everything organized and this file here in my project is where it should be in relation to this one here. Like, for example, let's have a directory named data, and let's move example.txt into our data directory. And now, this is nice because I can put all the files with my data in this data directory and have everything really nicely organized and have my project well organized. Right. And so now, this relative path is going to be good. You always want to know where you are, as you guys were saying. And in general, you want to always run code from the project base directory. And if I need to, for some reason, I can grab an absolute path this way. And I think just to kind of close the loop on this, we can use an absolute path to open that same file. I can open it because I want to write as well. I'm going to be totally honest. I'd have to look up how to add to something in the file. It's probably something like line equals f string new thing. I'm sure there's better ways to do this, but I'm curious what this does.
Instead of write, use A for append.
Say that again.
You have with open absolute path W for write. I think A append will put it at the bottom or at the end of the file.
Oh, to add a new line at the end of a file?
Is that what you're trying to do?
I was just trying to modify the existing lines, but appending to the end is also a good thing to be able to do.
Okay, I misunderstood you. My apologies.
No, no worries. And it looks like I got this wrong. Anyway, let's see what the error here is. Not readable. It looks like my absolute path has something wrong with it.
Can you plus
And
equals?
I'm not, sorry?
Can you use plus equal instead of equals? Line equals? You say line plus equals and then the string.
The issue is coming from IO unsupported operation not readable. You make a good point. Let's see if the write is working at all.
You have to use file.write.
Say that again, James.
So you got it named as file. Well, not right there, but when you're doing your for loop, you have to write to it. You have to use .write and write to it before you do your for loop, if I'm not mistaken.
Let's see. You know what? Let's simplify this. Let's start with keeping this what we've been doing and make this read. So that does seem to work, though it's not printing anything out. So I think I have something wrong with my pathing because I would have expected to see something printed out here. So let's see if this one works. Now that I've moved stuff around, I may have screwed something up. And you know what? I think I accidentally deleted something in the file. So this just goes to show I was going down the wrong path for the error. So it's always good to double check your assumptions. Okay, so both of these are working. The absolute path is working. I'm not going to worry about writing to a file. I got a bit too off the cuff. As you guys have pointed out, there's multiple ways to do it. The main thing is here, I think we've seen absolute pathing as well. And I think this is probably a good pause point because after this, we're going to talk about testing after the break. Do folks have questions or stuff that you are curious about before we break? And as the people's points here, we can kind of see you can open for writing. We can open, like you were saying, to append at the end of the file. We might have to do an extra step when we write to the file. Like you were saying, like James, like file.write. I see exactly what you're saying now. I'm not gonna open that door right now, and it's a little out of scope, and you guys can figure that one out. How are we feeling about Pats? Okay, awesome. Why don't we take should we take what, like 10 minutes, 15 minutes, and then we can talk about testing in Python?
Didn't we talk about testing?
Okay, got my afternoon espresso. I'm ready to talk about testing. We got introduced to the basic idea of testing yesterday. I briefly mentioned this term test-driven development and talked about it a little bit. Let's talk about it just a little bit more. And can everyone read this okay? Cool. So there's this term red, green, refactored. Write a failing test before you've written the actual code. Writing the test helps you design your function or whatever code it is. You know, if you had to think about the 99 bottles of beer problem, if you wrote some tests before you even wrote any code, it would force you to really think about the problem. Write the minimum amount of code needed to pass a single test. You do it one test at a time, right? So for 99 bottles, I might just write a test that I'm counting down from 99 to 1. And it forces you to think about each separate functionality or feature of your program. And programming is all about taking big, complicated things and breaking it into somewhat less big, less complicated things, and breaking it into smaller things until you have very small, absurdly simple things, and then making those. And so once your test is written, you then refactor. And once the test passes, refactor the code to improve it however desired while keeping the test passing. This is good to know about for a couple reasons. It used to be extremely trendy in the industry, and people felt very religious about it. It is still used at many companies. It's expected knowledge. I give it about 50% odds that the first software engineering job you have, they will want you to write code in a TDD style or something similar to it. Some developers hate it. Some developers love it. There are definitely trade-offs. I think something that's really valuable about this for all of you as early career software engineers is this is explicit. It forces you to think about design and it gives you structure. Why else does it matter? It improves reliability. And reducing bugs. Testing is not the only thing that matters, but it's one of them. Tests are living documentation. Maintainability, really the same thing. Collaboration, and something called regression testing. Regression. We fixed a bug, then it happened again. This happens way more often than you would think. It happens so often that programmers invented a term for it. And so when you fix a bug, you write a test for it, a regression test. Because if you think about it, like if a bug makes it past code review and all the other tests, it's probably pretty subtle, which means the odds of it happening again are higher than normal. For the programs you're writing now, all this stuff is a little abstract. For your personal project, it will start to matter more. For your group project, more. When you get out into the industry, it matters a ton. This is what employers care about because you're hired to be part of a 20-person team or a 10-person team in a software engineering department of 100 something people. Like, as professional software engineers, we're usually building houses, apartment buildings, or skyscrapers. And that's why this stuff matters. Do folks have any kind of questions around this sort of big picture conceptual stuff before we start writing code? Okay.
Can you define the term bug? Like
Oh,
you're not
yeah.
talking about you're not talking about a syntax error.
A bug is anything that is wrong. If it breaks the program, as in the program actually fails, that's a bug. Or if the program doesn't do what I want it to do, that's a bug. So a syntax error, if it causes the program to behave incorrectly, it could be a bug. It just depends on, what the syntax error is. Fun fact, anyone know where the term bug came from?
Actual
The
insects in old
literal
mainframes.
bugs that would get into the vacuum tubes, or not but
Yeah.
the computers on the scan cards.
Yeah, exactly.
cards, that's
Back when computers were like giant things that filled a whole basement with vacuum tubes. This woman who was actually became an admiral in the Navy and was like one of the first programmers. She invented functions or something like that. Something kind of mind-boggling and fundamental. This woman, Grace Hopper, who's sort of one of the queens of programming. So the story goes that like in her log that she or her team was keeping. Oh, and now they're telling me the story's a lie. Well, I don't really like that. But supposedly the logbook says we were looking at the vacuum tubes and we found a fly back there and we pasted it in there and it's a bug. And you know what? If that's not the truth, I don't want to know what's right. Anyway, let's write some tests. Let's cause some errors and bugs of our own. First off, with testing, we're going to need this library called Pytest. So you're going to install it with pip, which means we need that default virtual environment that we set up on day one active. For some reason, mine is not active right now. It's interesting. I'm going to run source tilde default bin activate. Now my command prompt has this default here, so I know that the Python virtual environment is active. I think all of you should have this already from the day one install fest setup. But now I'm going to do pip install Pytest. I already have Pytest installed. If we take a quick look at the Pytest library online, we can just take a quick peek at it. And we can see here, they have really nice documentation. I actually recommend pulling up their docs because their getting started tutorials very good. Their how-to guides are very good. Their API reference of all the things is extremely good, especially say Capsys that we'll be using a bit later. So Pytest has amazing docs. Once you've dealt with some terrible docs, you'll come to appreciate good ones. So I would have those open like as you use Pytest. And that's why programmers have so many monitors, so I can look at the docs and my code all at the same time. I can in fact go ahead and run Pytest, but there's no tests in here, so nothing interesting happens. It creates a cache directory that I don't have to worry about and that I can ignore. In fact, I'll just make a git ignore file to sort of simulate a real project. And in it, I'll tell it to ignore the Pytest cache directory. I'm going to go ahead and just make a really simple test file. And I think what I actually want to do, let me make another file here. And let's recreate the add two numbers function that we wrote earlier. But it's going to be empty. And we can do a little TDD, or test-driven development. And I wanted to make the empty function because now I can import it. And I'm going to use VS Code autocomplete to make my life easier. Let's write my test. Let's test that if I add 2 and 2, it equals 4. So we saw expect with jest. The general term is an assertion. This is a test assertion. Assert is saying, hey, this should be true. And when Pytest runs this test file, it will import the stuff it needs to interpret and run this. And this is also where having the Pytest docs are useful, because then you can look up assert in there and see all the details. Now I'm going to go ahead and run this. Pytest test example, and my test fails. And I see here all this stuff in red. Assert none equals 4 because this returns none because the function body is empty. And I get an error. So this is red. Now I want to do green and write the minimum I need to do to make this work. And I'm going to run my test again. And now my test passes. Good job, Adam. My code is done. I wrote a great function, right? I see a couple shakings of the head. Yeah, what's our problem here?
There's only
Is it
one
because you put
possible answer.
yeah.
Yeah. So what's dangerous about this particular, like, what's another good test to add here that will help me? Chase, you might be muted.
Could you do like make sure like the add two numbers doesn't equal 5 for 2 for X and Y? Is that what you mean?
Yeah, totally. In fact, let's add another assertion here. How about let's just add like maybe 1 and 3. I like to throw 1 in the mix, and that should equal, or let's do 1 and 4, and that should equal 5.
What was
And
the command
now,
Pytest again? I'm sorry.
sorry.
The test or the command to install Pytest into the virtual environment.
Oh yeah, pip install Pytest. So instead of npm for JavaScript, we'll be using pip Pytest gets installed to that default virtual environment directory that we created on day one. As long as we have that virtual Python and virtual environment activated, as they call it. So, I could put this in a different test block, but it's not the worst thing to have them here. And so right now this one's failing. So now I need to make this better. And I know this is a silly example, but it does point out this is actually not the worst just to get started. Why don't I now do like x plus y? And now let's go ahead and run my tests again. And now my tests pass. What might be some other good tests to write here, real quick? What kinds of inputs can this function accept? What different categories of inputs are relevant?
Floats and
Yeah,
integers.
I would try like type checking, making sure A plus B doesn't return it. I don't know what it would return, but
We could check they're both numbers for sure. What else? So that's good. What about valid inputs? Like, what are some gotchas or edge cases that we should be thinking about for valid inputs?
You mean like a float or something?
Yeah, a float's good because it's a different kind of number, right? 3.4, how about 3.33? And how about 6.333 and 3.333? And that should equal what? 9. Let's make this. I don't think we're going to get into the rounding issue, but I figure we might as well try. When you're dealing with numbers, what's the number that gives you the most trouble?
0.
Yeah, right? For addition, it's easy, but for multiplication, I might need to care about that. And we really should be testing negative numbers, right? How about let's make sure 2 negative numbers get added together correctly? Let's make sure a negative and a positive number get added together correctly. And I think that's pretty good range here, right? So when I'm talking about different categories of inputs, this is really what I want you all to think about. The type checking and checking for valid inputs, that's important. And that would be another feature to add as well. But it's important to think about like your categories and kinds of valid inputs because there are edge cases and stuff that pop up. And so now we've got all of these working. And let's say I want to write a test that makes sure we validate input. And what I want to do is I want to actually we'll come back to that one later. I don't want to that one's going to take us down a bit of a rabbit hole that I don't want to go down right now. So assertions are pretty straightforward. Let me just throw in a couple examples just so we can see them here. I can do like assert 3 times 5 doesn't equal 11. I can also do assert like hello equals hello. And let me just run this real quick. And we can also deal with assertion errors. And give me one moment here because I think I may actually be looking at some wrong syntax for this. Let's actually look at these docs to make sure I get this right because I do want to show the assertion error. And I think I may be forgetting to. Yeah, I think I forgot to import Pytest is the step I forgot. So let me give this a shot here and we can import Pytest. And now over here, I think I want to raise type error. Let me make sure I get sort of my syntax right in using this. So what I want is add two numbers. I want to check that both the first and second inputs are numbers. And if it's not, I want to raise a type error. And when I run these tests, they should fail because my test is not failing. Um, and I think I've got something. Because both of those should, yeah. So indeed, okay. Actually, I kind of outsmarted myself, folks. So let me show you how I got confused here just now, because this is actually quite useful. So when I run add two numbers, hello and 4, well, hello is not a number. And here we see type error can only concatenate string, not into string. Type error failed. I can't add two numbers together is basically what this is telling me. So I thought I was going to have to do like a check here for a type error. And actually, I would if I want to have input handling, but the method by itself throws the type error. So this is actually working as expected. This should throw a type error, and this should throw a type error. And then with it captures that error and says, yes, we're actually expecting the error. the downside here is maybe I want to return a message or something like that instead. Like if I wanted to say if type X is not number, let me do a quick check here.
Yep.
Int. So let's see what happens when I run these tests now. So now I get a couple things happening. First off, I need to deal with integers and floats. Second off, I'm not raising a type error. I can probably combine these, but I'm not going to worry about that too much right now. And now I run into a couple interesting issues. It looks like I'm getting invalid input, even though I'm putting something I would have expected to work just fine here for 4, but then we're also getting a failure here as well. I think the easiest way at this point now is actually, let me just run this by itself outside of the test and print out the output. And we'll see if we can't fix this, and then we will move on because I'm getting a little in the weeds of writing tests for things. So I've got something wrong with my conditional logic, but now it's working. So I must have the order of sort of precedence here was not correct without the parentheses. I want to say X has to be an int or a float, and Y has to be an int or a float. And now that does seem to be working just fine. And let's try running the tests now. And these were all working, but interestingly, I would have expected this last one to work. The type errors I want to fail. So let's take this one and put it over here and run it. And this is where, like, when you're debugging, you really need to see your errors and your data to know what's going on. And again, this is where I'm a bit surprised. And I'm just going to print out the types of these things. And so I have something wrong here because these both are floats, but it looks like my logic is wrong. I think we're hitting this and then failing. Though I would have thought that this would have worked for us. So
I think you might need that not keyword again after the or.
over here,
Yes.
yeah, I would have thought that int or float gives me what I want. Let's test it out like this. And this is why I like the REPL 3.333, type 3.333. Is float. Float or int. Int or float. So my error was I thought int or float. I thought I'm getting confused with my logic. I thought if it's float, then either of these would be true, but it's not working that way.
You can.
I think what I need is something like this. I need to have them be two separate statements, and I'll put these in parentheses just for clarity.
Yeah.
Though the
And you have to do the
parentheses
same,
aren't needed.
and you have to do the same thing whenever you use an and as well.
Yeah, I hopefully don't need the and here. Let's see if this works. And in fact, I really should put here X invalid input and Y invalid input to help me debug. You might be right that
Or
it does.
if. I believe if should be on both sides.
There we go. Okay. This is the problem. Like the later it gets in the day, the easier it is to make these mistakes. I keep thinking or will work for both just fine, but or means a failure happens for either one. There's definitely a better way to write this. My brain is just tired right now because I really want to make sure X can be an int and it can be a float. And now it's working for both of these because I want this to be false and I want this to be false. Yeah, I've got a double negative in here, and I'm going to just twist myself into words if I keep explaining it. So I'll just pause. I'll share the code with people later so you can see it. Let me run the tests and see if this works now as expected. So now I'm finally seeing what I expected, which is all these assertions work. But I'm not raising a type error. And so instead of doing this, what I would do now is this, right? Assert, add two numbers, hello, and 3 equals X invalid input. And then this one should be Y invalid input. Right? And let me run this and see if this works. And thank you all for being patient with me here. And now those tests pass. Right? And in fact, if I do 3 and 3, my function will add this together just fine, but the test fails because this test is explicitly looking for errors. So you've got two styles of input validations. Honestly, this isn't worth it. And if I was doing this, I would be better off returning some kind of error or exception with like a custom name that gets handled. But to be honest, for something like this, the default type error is actually best and simplest, right? And you all can see here how like this actually is exactly what I should want And my other code would do something like this. Let's pretend, user input A equals hello, user input B equals 4. We do try, add two numbers, user input A, user input B, and we do accept type error as E, and then we can print user, please enter a number, right? And so this method's only job is to throw an error. The code calling the method has the responsibility of handling the error and showing something to the user.
You have a hot mic, Chase.
So I went on a bit of a tangent here, but this is actually really good stuff to see. So let me just pause and see what questions folks have.
I have a quick question, more so about my follow along because I ran the with Pytest raises online 12 for me, and when I import it, the test runs fine. And both of them they all passed, but at the top where I put import Pytest, there's a squiggly line saying something's incorrect.
Yeah, that's a great point. If you all see a red squiggly in VS Code, but everything works fine, that means VS Code is looking in a different place for Python and everything you install with pip than where you actually did it with the Python virtual environment directory. And that's where you want to do the select Python interpreter, and you would then get the path to your virtual environment directory and paste it in here. And in fact, mine is all messed up for some reason, but it's working fine, so I'm not going to worry about it right now. That's
Sorry.
almost definitely going to resolve the issue.
How do you switch that again? Because I got that same thing.
Yeah, Command-Shift-P,
Okay.
Python, if you just type like Python interpreter, Python select interpreter, if your virtual environment is activated, you can type which Python 3, and this is the path, and I think this is the path you can drop in. I think you just want the virtual environment path. You don't need Python at the end, so it would look something like that. Yeah, thank you for circling that. Oh, yeah. Yeah, I'm not going to worry about that too much right now because, to be honest, I always get a little confused with this and it's a little out of scope. As long as the code is running, right now, that's the main thing. Let me quickly show a couple other nice things you can do with assertions. Then let's take a break and then let's see some more advanced testing capabilities that we will need. So let me close this one out because we're not going to use it. And let me just start adding more assertion examples. So here's some more cool assertion stuff that we can do. I can assert that something is in a list. And I believe if I do assertion examples dot only, let's see here. Let's only run this test, and let me show you that as well. And my apologies, just one moment. We have to do it on the command line with Pytest. So let's see here. Oh, I think we might have to. Yeah, my apologies. I will come back to that one. 'Cause I feel like that one should be working, but I think I might just have a typo that because it's in the afternoon, my brain might be missing. So let's just run the tests for now. Um, we can find that something's in a list. I can assert that something is not in a list. I can assert that something starts with a string. Or ends with a string. I can assert the length of a list. That might have to be a double equals. And it, in general, I can use all the other things we've seen, like with sorting and stuff like that, to test the different qualities of stuff. Like I can also test that, um, like some sorting occurs correctly. My apologies. Um, so it's definitely worth taking some time just poking through the Pytest docs. You can see these things here. Hiding somewhere in here is probably what I was trying to do that I was failing with. To skip a test or only run a certain test, though it gets a bit more complicated. Um, and just in general, you can do all sorts of stuff with Pytest. Let's take a break in just a minute, and then we'll see how we can actually capture command line output and test it. Why don't we take a short break? But before the break, do folks have any questions or things that it might be good to go over?
Can you test using actual variables instead of their expected values? Can you assert that variable X is going to behave in this way instead of saying variable X is hello world?
Um, yeah, you can assert anything, but you don't want to end up with, let's say X equals 5. You don't kind of want to end up with this. It's kind of nice to hard code in the correct values because that's part of the point of the test, right? But you could do something if you care about, assert X is greater than 3 is true. I don't know if that's what you mean.
So more like the type testing above, if I could just say, I know that X and Y are the variables in the method that's being passed. can I just say assert variable X type is string, and if it passes, then it's a string, and if it doesn't, then it's going to fail.
Oh, I see. No. The way to think about it is this. What I'm testing is a function. And the whole value, in fact, of a test is that whatever happens inside the function is a black box. And there's an asterisk there because we'll see that later. But in essence, I care about inputs and outputs, and that's what I test. And if I really care about something inside here, then maybe this needs to be two separate functions, and then I can write a test for that other function that I use in here. Does that help answer your question?
Yeah, I understand.
Yeah, great question. There is an asterisk there, and in fact, we'll see that after the break with capturing system input. But you raise a good point. Part of the value of testing is it forces you to organize your code, and it lets you start to work at a higher level. Because at a certain point, I don't care how this addition works. I just care that with the right inputs, I get the right outputs. I know I lost the thread a bit. Let me pause the recording and let's take a break, and then we can do testing. I think we should probably just power through, but let's discuss.